Awesome. Thank you very much, Dipti. So started here. So good afternoon, everyone. My name is Roy Hasson. I'm a manager at AWS. I lead a team of analytics specialists that help customers build modern data platforms that solve any type of business problem. Lots of them. I've been working with Presto since we launched Amazon Athena at reInvent 2016. And I'm actually really excited to be presenting in front of this amazing Presto community. Really love the community, a lot of awesome people. With me today is Jonathan Chase. He's Director of Engineering at Agari. He will walk you through how they built a serverless data processing and analytics platform on Amazon Athena utilizing the power of Presto. Before we get there, actually, I wanted to take a few minutes to introduce you to Amazon Athena and also talk or kind of highlight one specific innovation that we've been developing that I'm really proud of. All right. So Amazon Athena, serverless query service for data in your Amazon S3 based data lake using common standard file formats. Pretty simple. It leverages the scalability, functionality, and even the performance of Presto, allowing our customers to quickly onboard new use cases. Some common use cases we see are, first of all, querying your data lake without needing to duplicate data or move data around, and only having to pay for the data that you scan, so no infrastructure to manage. In your data lake, you may have any type of data, but we commonly see Athena being used to query infrastructure, security, and even application logs to be able to quickly identify patterns and even root cause issues. We also commonly see customers use Athena for interactive queries with popular BI tools like Amazon QuickSight and Tableau, as well as ad hoc data exploration using Jupyter Notebooks, CLI tools, and even scripts using our APIs. So as you'll hear more from John in a little bit, Athena can be used for SQL-based ETL using create table as select, insert into functionality to create powerful but yet simple to manage data pipeline. That's kind of the key here. Also becoming more commonplace with our customers is embedding analytics into their applications. So you can use something like Amazon QuickSight, which is our dashboarding BI tool, connected to Athena as the backend to embed analytics and visualization directly into your application with little to no effort, right? So you don't have to build your code around it. You simply use our APIs and our SDKs and embed it in. Okay, so now that you have an idea of what Athena is and how it's commonly used, let's quickly look at the architecture. It looks pretty simple, and I'm obviously ignoring service-specific piping here, but at a high level, the Athena service exposes a REST API that accepts SQL statements and executes them on Presto workers inside of an AWS service VPC, right? For security and performance reasons, each query gets its own Presto resource. When queries complete, these resources are cleaned up, they're recycled, we discard all the data, and then we make them available for more queries. Data is read from a customer-managed S3 bucket. So the customer is always in control of their bucket. They can encrypt the data on their own. If the keys are managed in KMS, in the AWS Key Management Service, we can leverage that. And then the results of your queries are also saved back into a customer-managed S3 bucket, again, can be encrypted. Pretty simple, secure, and fast. So that's kind of the gist of what Athena is. One of the most powerful and really exciting features of Presto, at least in my mind, is its plugin framework. And customers have been asking us for a little while now to expose similar capability inside of Athena. And in reInvent 2019, we announced a preview of our plugin framework. And this is what I'm representing here on the screen. So we wanted to come up with a solution that was scalable, flexible, and also highly configurable that can address many types of use cases rather than just focusing on data sources or federation, give you the option to create more connectors and more ways to interact with your data. So we decided to build a solution on top of AWS Lambda. That's our serverless compute platform for that particular reason, because it gives you flexibility. We developed an SDK that exposes the query details and hooks to interface with the metadata catalog, right? The glue data catalog, or even a Hive metastore, and other variables, and that you'll need to implement your connector. So giving you all the information you need to be efficient. We've also implemented several use cases, starting with federated query support, what you see here. This really allows customers to use our connectors or create their own to read data from their data sources like Postgres, MySQL, Redshift, DynamoDB, etc. Or you can create your own into your own data sources, however you like. The SDK that we provide supports predicate pushdown. If the data source supports it, we'll push that information to it. Partition and split management, so we can parallelize queries over multiple Lambda functions. So instead of having a single Lambda function opening a connection to your data source, we can actually open multiple Lambda functions opening multiple connections, right? So parallelize the data access. And also we implemented support for spill to S3 for data sets that are larger than the available Lambda memory. So that kind of helps you, especially as you're distributing this across a lot of Lambda functions and you're moving a lot of data. And then finally, I want to call out that the SDK utilizes Apache Arrow to efficiently transport data from Athena to your connector and then back to Athena. So now, because we have this Lambda-based implementation, we can also implement other use cases like user-defined functions. We have customers that use it to encrypt and decrypt fields, specific fields in their data. For masking, you can apply different business logic or even implement custom transformations as you're using Athena for your SQL-based ETL. But my favorite is actually integrating with machine learning services such as Amazon SageMaker to make predictions directly from your SQL tool. So instead of creating custom applications for your users to interact with your models, you can actually register those models directly in Athena and simply pass the result of a select query to the model and get predictions right back in your SQL tool, right? So if you're in QuickSight or Tableau or SQL Workbench or whatever, you get the results right there. So it's super easy, right? And it ultimately keeps the users in the tool of choice and the one that they're most familiar with, and also gives you, the person who's building the models, the ability to expand the reach of your models and the impact of those models, right? You don't have to create custom applications and train your users to go use those applications. If you didn't want to create your own models, you can actually connect to AWS AI services such as Amazon Forecast to create forecasts, or connect to Amazon Comprehend, for example, to use natural language processing to parse user comments or other unstructured data. The possibilities are really endless here, and that's really the power and why I chose to kind of highlight this capability here to you guys today. It's because I'm proud of it, first of all, and again, I think this provides an extension both to Presto and to Athena for our users to be able to do a lot of things. So with that said, I hope you'll give Athena a try. It's easy, really easy to get started right in the AWS console. You can query your data in S3 very quickly. We also open source the SDK for creating these plugins. So please check it out, and I hope you go create some really awesome stuff. So with that, now I'll pass it on to John. So thank you very much. John, you want to take it over?
Great, thank you, Roy. That was fantastic. I'll go ahead and get my screen share going here. Give me just a moment. So I'm going to talk to you about how we implemented an ETL pipeline with Athena at Agari. So let's go ahead and get into it. So quick agenda, just to touch on Agari, just to let you know what it is we're doing so you can kind of have some context. Then we'll talk about why Athena and Presto were a really good fit for us, what we were doing with this ETL project. Then we'll cover some of the nuts and bolts of actually how we did some of this work with some interesting patterns. And then a couple of next steps, we'll actually touch on a couple of things Roy mentioned already in his slides in terms of features that we might look at implementing at Agari. And then we'll wrap up with QA. All right, so Agari, we are an email security company. We deal with, basically detecting malicious emails. And so to do that, we do a couple of things. We process a lot of data and we do a lot of machine learning. Unfortunately, a good problem to have is that our data volumes keep growing. So this is, sort of what brought us down this path looking at Presto and Athena. Myself, I'm a director of engineering at Agari. I like distributed systems, been working with distributed systems and big data for a couple of decades. Also contributed an Athena component into Apache Camel. So Apache Camel, if you're not familiar with it, lets you work with a lot of third-party services and APIs in a very sort of integration-centric way. So give a look at that if you're using Camel already. So I'm going to give you the challenge that we had here. So we had a small team, and we wanted to process a lot of data to basically cook it down in an ETL pipeline so that we could give our customers some dashboarding to kind of show the value, right? So show them some high-level metrics. And we had outgrown our existing system, so we needed something that was going to scale better and that was not going to be operationally complex. So we came looking, we're a heavy AWS user, and so Athena obviously was one of the things we wanted to look at and evaluate. So I'll step you through a couple of these considerations that we went into. This is just a quick sort of dashboard view of some of the data that we present by cooking it down in Athena. So very custom or standard, business analytics dashboard. So growing data sets, right? Perfect fit for something that scales horizontally. You can see here our projected growth. We're doing about 3 billion events a month. We burst around 3,000 a second. Pretty wide rows in terms of the data structures, and about 100 terabytes total that we have to deal with. So we had this on a Postgres database. This is the standard startup story. You start small and start with something small like Postgres, but at a certain point, it just doesn't scale anymore, right? So in terms of the data set growth, Presto and Athena were very attractive for us because we knew it would be able to scale out horizontally with our growth. I mentioned we had two folks, right? So we needed to be very operations light. Athena being a fully managed service was a great fit, right? There was nothing to install, nothing to upgrade. We don't get paged when it goes down. The engineers at AWS do. And then likewise for S3. So the integration between the two is really nice. But we liked that it was serverless and that we're not having to deal with provisioning and maintenance. You basically get that data into S3 and you get going. Waste is a big thing, especially when you run in a cloud provider. It can be very easy to run up a bill if you're not cost conscious. So Athena gives you lots of visibility into that cost, and then also a lot of control over how the cost is accrued. So two things in particular to mention. One, how you store the data. Partitioning is a very common practice in big data stores. So we use partitioning heavily. That really helps cut down both on query cost and query times. And then also we do a lot of Parquet files. So Parquet has been super helpful. We started prototyping with, JSON files and scanning the whole file as opposed to just columns. Drastic, order of magnitude difference in cost. And then finally, this is an ETL process that runs offline daily. So there's a lot of time when we don't need the servers provisioned for this job. It's only really one time of the day when these things kick off and run. And of course, if people run interactive queries. So it's nice to not have to pay for those servers, right? There's a pool of servers sitting out there for Athena. We submit the queries, they get picked up immediately and start running. I mentioned we looked at relational databases. We actually were using Postgres and we're big fans of that. But at a certain point, it just doesn't scale. We looked at some other types of data stores. A big consideration for us really is SQL support. That's sort of a lingua franca, like a common language at Agari. Most folks can understand and write some SQL. And so it's really handy to just be able to give people an Athena console and say, here you go, have at it. Okay, great. So I'm going to dive into now sort of the hands-on piece. I'm going to talk a little bit about, one, our data ingest pipeline, which is how we get the data into S3 and Athena. And then I'll give you a little more color around the ETL pipeline piece of this. But I wanted to give both pieces because I think it tells an interesting story of a truly serverless architecture and how that fits together. So we ingest our data. It comes in from Kinesis. So we have hundreds of clients sending data into Kinesis. And once that data lands into Kinesis, we need to get it into S3 so that Athena can query it. So this is high volume data. It comes in a custom Avro format. So we use something called Kinesis Data Firehose, which takes that data off of Kinesis and is basically a stateless service to manage buffering and flushing the data into S3 or another, you can send it into Elasticsearch or something like that. So Firehose understands JSON. So what we have is just a little Lambda that can translate our custom Avro format into a JSON blob for the Firehose. And then at that point, the Firehose can send it to S3 and batch it as Parquet files. So it's really nice. You get these nice, compact, big Parquet files kind of optimized for what you would want in a Presto Athena scenario, right? So firehose handles, even at very high volumes, getting that data into S3 for us as Parquet. On the other side, we've got lower volumes of data. This tends to be like, if you're thinking of like a star schema with the Parquet data, the large volumes, that's sort of our fact data. Then the JSON would be our dimensional data, right? This is like the users and the organizations and settings and things like that. You tend to want to join those in your queries. So having these dumped into S3 as JSON, we use glue crawlers, which is another serverless offering from AWS. That will actually go in and infer schemas from JSON files. And then those schemas are magically available in Athena to write your queries against. So it's a really nice model where we add new fields to these JSON files, and glue crawls those files, infers new schema, and suddenly they're magically in Athena. So, and then there's Athena sitting in the middle. This is sort of at a very high level. This is our ETL pipeline. Send it in through Kinesis, firehose it into S3, right? So now I'm going to walk you through the ETL pipeline that we developed for our use case. One thing, again, you'll notice here, it's a serverless solution. We don't do everything at Agari as serverless, certainly not. But this, we felt like it was a perfect use case where it just really fit for us. So you will see at the center of this a Lambda, and that's sort of the coordinator. And then you'll see Athena running queries. You'll see query results landing into S3, and you'll see finally RDS in a Postgres instance. So I guess not technically fully serverless, but pretty close. That's what we store the final results in, and that's what we serve to end users. So it's very snappy. So to kick off any ETL process, everybody knows you need a cron job. So the serverless version of that in AWS is CloudWatch events. It's just a cron. So this basically fires off a trigger that kicks a Lambda off. So we wrote this little custom Lambda. There's really not that much to it. It just has a couple of different code paths. So when this the event kicks off the Lambda, that basically says, hey, wake up, run all the Athena queries, and go back to sleep. So that's exactly what it does. It's got a backlog of Athena queries that it runs. It submits all of those to Athena. Athena starts running those against the data that's in S3. Those are all joining, those queries are joining both the large Parquet data sets with the JSON data as well. So at this point, the Lambda's job is done for the time being. Athena runs these queries in the background. And at some point, it deposits the results. So the query results from Athena get deposited back into another S3 bucket as CSV files. Now, you can save query results depending on your use case from Athena, Avro, JSON, CSV, Parquet, ORC, but the default CSV works great for our case, and you'll see why as we get into some of the Postgres screens. So at this point, the query results have landed into S3. Those S3 files getting put trigger another event to be sent to the Lambda. The Lambda wakes up, it says, a new file has landed in S3. This must be a query result for a query that I initiated. So why don't I go ahead and pull that file, load it into RDS, a Postgres instance, and then at that point, its job is done. So the RDS instance, of course, there's a web front end in front of that, but that's how users are going to then access the report. So at this point, we're talking the billions of events pulled out of Athena. We use the ETL, and then the RDS instance, we're talking, thousands of rows per day. It's very small volume. So in this sort of big picture here, the ETL, Athena is really the extract and the transform. We do a lot in these queries. I don't have the full queries to show you, but suffice it to say that some of them can be pretty large, and we can do a lot of transformation. Athena and Presto has a lot of great transformation functions. And then the L, the load portion of this pipeline, is really covered by the Lambda. So I'm going to step you through a couple of specifics here and some patterns that we found useful when working with Presto and Athena in this pipeline. So what I've got here is actually a dump of one of the result files. So at this point, Athena has run the query. It's dumped the results as CSV into S3, and we're looking at one of those results files. So the first thing to notice here is that it's CSV. Postgres does great with CSV. The second to notice is that we have the column names at the top of the file. So the first line of this file is the column names. These just so happen to coincide with the column names in Postgres. So this is perfect. If you want to change your table schema in Postgres, you just go update an Athena query. You can say select customer as customer ID, and boom, you have your columns correctly. So this works out, and I'll show you why in a couple of slides. And then the rest of this file is a plain CSV file. There's really nothing too exciting about it. Next, this was a little trick that we used to be able to keep things fairly stateless in our processing. So like I said, we tried to do a full serverless solution for this. We didn't want to have to deal with any additional state tracking. So one of the problems that we ran into was when a query completes and the files land in S3, this Lambda gets notified. Well, it gets a pointer to the file, but it doesn't know what table should I insert that into in Postgres. And so one little trick we came up with, which turned out to be a pretty nice pattern, was we embedded, so what you're seeing here is the first line of the Athena query. So we put a dash dash, which is a SQL comment. So Athena itself is going to ignore this part of the query, but inside we embed a bit of JSON metadata. So here you can see we're saying the target table for the results is a Postgres table named my Postgres table. So when that file lands in S3, the query results, the Lambda gets triggered, it gets a pointer to the file in S3. It also gets a pointer to the Athena query that originally ran it. So we're able to use that to basically dereference, look up the original query, and we can say, aha, this file that just wound up in S3, here's the table that we're going to place it into. So then this last slide, and then I'm going to move on to our next steps, and we'll go to QA. This last slide sort of ties it all together. So this is just a little snippet of code from the Lambda. Again, I think the thing I really want to stress in this one is that there's really not much to it in terms of ETL, aside from running those queries in Athena and then getting those results into Postgres. And this is almost the full extent of the code required to get the data into Postgres. So let me walk you through it because there's some detail in here. So first off, this S3 input stream, that's an input stream to the file in S3. So we don't need to load the whole file into memory. We just need the connection to the file in S3. So we have an open socket at this point. Right? So that came from the event of the S3 file being deposited into S3. So we have that input stream. The next thing we do is we read the first line off of that input stream. And you remember a couple slides ago, I showed you the first line is the column names. So that works out well. So now we have our names for the columns. Postgres needs those because it needs to know what data goes where. And then we have the target table, which I showed you in the prior slide. We were able to dereference that as well from the event we got in the Lambda. So now to do a copy into Postgres, you need a target table, you need the columns, and you need an input stream. So we have all of those things. Once we have them, we can use a native Postgres operation. Now, what we're looking at here, this code is Java, so this is JDBC, which is sort of like a generic wrapper around all databases. What we do is actually unwrap that connection to the underlying native Postgres connection. And then we use a native Postgres operation called copy in. Copy in takes a table, takes columns, and it takes an input stream, and it does the rest. So this is actually all the code we need to do the load into Postgres. So we think this worked really well because there's nothing else additional to do here. File lands in S3, and it's a very easy process to get it into Postgres for our users to use. So that wraps up my portion on sort of the deep dive or the technical details. Just a couple of next steps to touch on, things we're considering doing further. Partition projection is a new feature. I didn't show you, we do manage partitions. There's a little bit of code that we had to write to automate that. Athena now has a partition management feature built in. Both decreases the complexity of the code we need to maintain, which is always good, and it can potentially speed queries up over heavily partitioned data. So we're looking at that. We're also looking at maybe using the Athena component that I mentioned for Apache Camel just to reduce some boilerplate. And then as Roy mentioned in his excellent presentation, the federated queries option is very interesting. I mentioned that JSON data that we have in S3. That's great. If the data is not already there, we have to do the work to get it into S3. So the benefit of these federated queries is that we could say, talk to Postgres directly, and that just gives us more options in terms of the data that we want to query. So with that, I'm going to stop sharing my screen and we will open it up for QA.
Yeah, that's absolutely fascinating. I have to say, this is Eric Cavanaugh here. I was in earlier today and had to do some webinars in between. But if I understand it correctly, you're using Presto as almost like a Rosetta Stone to enable Athena on the front end and whatever your users want on the back end. Is that right?
Mm-hmm. Yeah, I mean, yeah. So Presto and Athena, are effectively the same thing. Really, Athena is that wrapper around it, and it's the sort of the serverless version of it. But yeah, I think that's right. We use that, like, again, as the ETL. So whatever the data format is in S3, there's a good chance that Athena can use it. And so it's fairly easy to write the queries to parse that data and to format it however you need for presentation later.
Well, and I think that's the key, right? Because consider me a layman of sorts. I don't understand the complexity of some of these solutions, but what I do understand is that users have their way of doing things. They have their current set of technologies, their current environment, and what you're able to do is really cater to whatever that environment is using Presto as the sort of intermediary. Does that make sense?
Yep, definitely. And I think, like I mentioned, for us in particular, like SQL support specifically is a big deal for us. I mean, we've had folks from other departments that we didn't even know were technical, pulling data and writing reports and things like that, just because it's SQL and it's easy to sort of grok.
Just to kind of add to that, I do see a lot of customers that are coming from traditional sort of data warehouse world, as much as we want to call those, SQL Server data warehouses, Oracle, and just kind of saying, we already invested all this effort and time in SQL. That's what we know. Can we unload that data to S3, which is cheaper for us to store, and then use something like Athena to run those transformations instead of maintaining big databases and moving data from database to database. Many times it's an ELT database and a serving database. Now you can do it all inside of S3 using Athena in a serverless environment and save yourself a lot of time and money.
Yeah, that's really pretty impressive. And I think you hit another nail on the head there, that you have all this existing talent and you want to be able to leverage that. I think it takes just a little bit of time for people to kind of ramp up to do what you're talking about. Jonathan, you talked about how occasionally you need to write a little bit of code to automate something, but really it's a relatively simple process to put through, right?
Mm-hmm. Yeah, it's not too difficult. I mean, I wanted to show that ETL step, or the data ingest as well, to explain where that data comes from, because that's the value is the data. But once you have that in a place that Presto can query it, it's very accessible to users. There is one question in the chat: why do you need Postgres? Can customers query in real time from Athena? So maybe Roy can touch on this in more detail, but the quick answer from us is, one, we certainly need to reduce the volume of the data that we're returning. So those Athena queries that run nightly are going over billions and billions of rows of data. The data that we're serving up in Postgres, it's down to thousands, right? We've cooked it down to the bare minimum of data points. Athena is generally not considered, and Presto are generally not considered great for real-time use cases, especially if you were to have a large sort of onslaught of users. You don't want to run a bunch of queries in parallel. That could get you into trouble with resource limits, but I don't know if Roy has anything to add there.
John, you touched on a key point here, is that Presto and Athena obviously, so it's more for like OLAP type of queries, so more complex aggregations, windows, those type of things, and typically once you've built sort of those materialized view, if you may, loading them into a transactional database for serving purposes tends to be kind of an ideal situation, especially when you're connecting it to an application that may be seeing thousands of concurrent connections or anything like that, right? It's a better platform for simple lookups as opposed to running any kind of aggregations or joins, which you'd use Athena for.
Yeah, and I guess,
so think of it as like a serving layer.
Yeah, I guess in closing here, what I see as someone who has tracked data warehousing for 20 years is that Presto is providing this stepping stone to the future, to thoroughly hybrid environments, hybrid cloud, on-prem, et cetera. It's the stepping stone. It's the conduit through which you can touch all these environments and serve all those constituents, right?
Yep. Yeah, exactly. That's why Presto is so awesome and so impressive, right? Is just that the community is thinking ahead and is thinking in those directions, and implementing all these different capabilities that our customers can leverage. And John just kind of showed us that, and there's going to be more and more. And I think the hybrid cloud, the multi-cloud, is going to be a really interesting one. How do we solve that problem for massive amounts of data? I think will be really interesting. But Presto is definitely positioned well for that, and I hear a lot of customers using Presto with the word kind of virtualization, right? And it's an overloaded term, but in essence, basically, how do I virtualize my data platform by giving my users a single point of entry for them to be able to create the data regardless of where it sits, right? And that's the real power of Presto. So I think over the next year or two, we'll see a lot of amazing innovation, both from the Presto community, but also from users and customers, deploying this in the field and doing some exciting things with it.
Yeah, and there's a question for Roy here. Will Athena be available on AWS Outpost for on-prem? Of course, Outpost is their play for local regions and even for IoT type solutions. But go ahead, Roy. What do you think about that?
Yeah, no, good question. I can't talk to the roadmap. It's currently not supported on Outpost. However, we do run Amazon EMR, which is our managed Hadoop platform, on Outpost. And we do have support for both Presto DB and Presto SQL. So you can still use Presto on Outpost, but not Athena yet.
Okay. I think we're at a break, folks, but this has been absolutely fantastic. It's bewildering and it's amazing. I guess maybe one final comment I'll throw up there, maybe Jonathan or Roy comment on this, because there's going to be more innovation in the Presto community. We've built this layer of abstraction now that essentially allows you to, in a certain sense, future-proof your analytical environments, right? Because you'll be able to take advantage of new solutions that come on board without sacrificing all the existing, the legacy systems, the legacy, personnel, and et cetera. It's a way of future-proofing your analytic environment. Is that a fair assessment, Jonathan?
John, you want to take the first crack at it?
I think so. Yeah, plus, we actually have other applications that we use this data for that are outside of Athena. The key is that that the data is in a format, at least for us, the key is that the format of the data is a common one now, right? So Parquet or Presto or whatever it is, having that all centrally located, that for us has been the key, in that we can deploy a bunch of other functionality on top of that. We pull that data in many different ways now, so not just from Athena.
Yeah, and then just to echo what John was saying, I think that's absolutely spot on, and that's why when you see AWS services, we tend to have a lot of this decoupling of compute and storage and even metadata. That gives you the flexibility, right? If you're using Athena today and you're happy with it, great. But if tomorrow you want to use something else, the data should still be portable and accessible, using open file formats. The metadata should reside outside of the service in a place that you have easy access to it. And then you can bring your compute and do what you need to do. So I think that's a really important aspect, that the code that you're writing, SQL or even UDFs, and the data that you have are portable, right? We don't want to say, oh, just use some proprietary language for UDF, and then, tomorrow you're going to have to pay professional services $1 million to go, port it over, right? So it's all using open standards on everything. It just makes our customers' life a lot easier and future-proof their architecture.
Mm-hmm. Yeah, maybe one last kind of curveball question for you guys. Alternative data is such a huge space these days. It started off in financial services, institutional investors, et cetera, but it's really spreading out now to marketing departments, to business strategists, et cetera. And I've seen a move towards these alternative data depots, if you will. And what you were mentioning about file formats, I'll throw it over to Jonathan, is a really big deal, because if you have that problem solved, then you can onboard some new set of data very, very quickly and start using it, right?
Absolutely, and I think Roy hit the nail on the head there. It's really, the paradigm has shifted. You now bring the compute to the data. The data is the valuable IP. That's the distinction, where the data and the compute are separate. As long as that data is in a file format or some sort of format that's sort of an industry standard or well supported, then you have a very good high probability of getting that data into another system.
Yeah, and maybe just for clarification, Herrick, what do you mean by alternative data?
So all of these alternative data sets, there are hundreds, in fact, thousands is what I've been told lately. Credit card transactional data, for example, that's used by companies, all kinds of different things. Yep.
Yeah, no, absolutely, right. And that's the beauty of Presto, again, and John said this, right? You got to bring the compute to the data. And with federation and all those capabilities, right? If that data, the credit card data, is stored in a highly encrypted, Postgres database for security purposes, that federation capability with the right credentials will allow certain users or authenticated users access to the data, but others no, right? So you have the ability to kind of stitch those data sets together based on user credentials and what roles they have, right? And I think that's the power of Presto. That's why I'm really excited about kind of the future of Presto and what the community is building. And within AWS, we're providing an open platform that allows our customers to build these things, right? And over time, we'll be making it easier and easier as we all innovate and we find better solutions for these problems. But yeah, no, absolutely, there's going to be lots and lots of data sets, and we're going to have to be able to analyze all of them.
Wow, you guys blew my mind. That's fantastic stuff. Thank you so much for your time today. Thank you for your presentation.